So far, we've got about 5 properties that we know about. A couple of them involving multiplication, a couple of them involving division, and today I want to look at 2 more, the zero power property and the negative power property. Let's take a look at 5 to the second divided by 5 to the second. Well, we know from our quotient property that when we're dividing 2 powers that have the same base, we keep the base the same and subtract their powers. So 2 minus 2 is 0. But another way to look at this, 5 to the second over 5 to the second, well, 5 to the second power is 25. And in the denominator, 5 to the second power is 25. And when we have a fraction where the numerator and the denominator have the same values like that, they cancel, and that equals 1. So we could say that this 5 to the 0 is equal to 1. And there's nothing special about that base at all, that if my base is a variable, x to the 12th divided by x to the 12th, we use the property 12 minus 12 is 0. But if we use what we know about fractions, that when the numerator and the denominator are the same, they're going to cancel and equal 1. That's the zero power property, that if we take anything to the 0 power, it will always equal 1, no matter how messed up it looks. So if we have some crazy expression, 2x to the 7th y over negative 5z times 1/3 a to the 4th, and this is all taken to the 0 power, it doesn't matter. Anything taken to the 0 power is equal to 1. I want to think about that quotient property again, that when we have the bases that are the same, what we need to do is to subtract their powers. That was because x to the 5th means we're going to take x and multiply it by itself 5 times. And in the denominator, x to the 3rd means take x and multiply it by itself 3 times. And what ended up happening was, for each of these common factors, they canceled, and we see that we were left with 2 more x's, right? And it's because of that canceling that we could subtract, and we were left with just x squared. So what about when I have x to the 3rd over x to the 5th? Right? If we were to subtract those two, 3 minus 5 doesn't leave us with 2. It leaves us with negative 2. Right? If we look at this as a canceling problem, that in the numerator we have x to the 3rd, so that's x times x times x. And in the denominator we have x to the 5th, so 1, 2, 3, 4, 5 x's. And then we're going to go through and cancel those common factors, just like we did before. And we still have 2 of them. But notice that both of those x's aren't in the numerator anymore. Now they're in the denominator. So that x squared moved down to the denominator, and our numerator is 1. And so if you check out our result, we said that that expression was equal to x to the negative 2, and that is also equal to 1 over x squared. And this is an example of the negative power property. That whenever we're dealing with a negative power, we just take the entire expression, put it in the denominator, and the power becomes positive. So if we have something like x to the negative 5th, we'll go 1 over, put that in the denominator, and the power becomes positive. If we had w to the negative 30th, right, we keep the same thing, and because the power is negative, we put it in the denominator, w to the 30th, and leave the numerator as 1. So let's try a few examples. If we have b to the 4th, c to the 0, divided by b squared c, when we have these different bases, I've been taking them and splitting them up into 2 fractions, b to the 4th over b squared times c to the 0 over c. And when we simplify each fraction, because we're dividing, we're going to keep the base the same, and then just subtract their powers. 4 minus 2 is 2. And for c to the 0 over c, we know that anything to the 0 power here is going to be equal to 1. So that fraction is the same as 1 over c. Now when we put these two back together, because b squared is like b squared over 1, we multiply straight across the top, b squared, and straight across the bottom, c, and there is our simplified fraction. If we have AP being squared divided by p to the 7th, we're first going to have to deal with the numerator and simplify that. Because I have AP taken to the 2nd power, that's the same as taking a to the 2nd times p to the 2nd over p to the 7th. Because I have two different bases, I'm going to split my fraction up like this and just have a squared times p squared over p to the 7th. Simplify each of them. A squared is already simplified. But p to the 2nd divided by p to the 7th, we need to subtract those two powers. And 2 minus 7 is negative 5. We don't want to leave our answer with any negative powers, so that negative 5th power that's on the p, right here, to make it positive, we're going to put it in the bottom of the fraction, and then it'll become positive. That a to the 2nd is already positive, so it's going to stay in the numerator. And there is our simplified fraction. Here's one that can be a little confusing, but let's take a look at that. X to the 4th divided by n to the negative 5th. Because their bases are different, we can't combine those two together, so that numerator is going to stay as x to the 4th. But in the denominator, you notice that we have that negative power. And with a negative power, we make a fraction where that n to the 5th will go in the denominator to become positive. But now I just made things worse. Now I got a fraction inside of a fraction. But we know that when you divide by a fraction, it's the same as multiplying by the reciprocal. So the reciprocal of 1 over n to the 5th is n to the 5th over 1. Now when we simplify all of this, because we're just dividing by 1, we'll simplify to x to the 4th n to the 5th. So kind of a shortcut of all this, let me rewrite the problem real quick. That if we start off with x to the 4th over n to the negative 5th, whenever we have a negative power, like in the denominator here, in order to simplify, what we can do is just take it and move it to the other side of our fraction, and then it will end up with a positive power. All right, and that's how we can get that same answer a little bit quicker. So how about this last one? When we have 5v squared w over 20v to the negative 6w, and we want to simplify it as fraction. Since we have kind of three different types of factors in the numerator and the denominator, I'm going to split that up into 5 over 20 times v to the 2nd over v to the negative 6 times w over w. And then start simplifying. You should know with 5 and 20 that 20 is 5 times 4. So we cancel that common factor of a 5 and we're left with 1/4. For the v to the negative 6, like I just said, we have a negative power in the denominator. To make that power positive, we just move it to the other side of our fraction. So we'll have v squared times v to the positive 6. In our last fraction, w divided by w, those are the same, so they're going to cancel. Now we just have to simplify what's left. V to the 2nd times v to the 6th. Since we're multiplying, now we add those powers together, and we get v to the 8th. If you want to write it as one fraction, v to the 8th is v over 1, so we would have v to the 8th over 4.